All right, guys, welcome back. It's felt like a really long time since we've done one of these. The big, long Christmas break, but we're going to get right back into some new stuff. So really what's changing now is in the past, we've given you a problem like this one that says, what is the value of X? And it gives you some information, and it wants you to solve for X. What we're changing now is instead of just solving for X, you have to justify each step. And what that means is, for example, in this problem, it says that the ray AB bisects this angle RAN. So I know that angle RAB is equal to angle BAN. I know that this angle right here is equal to this angle because AB bisects it, which means it cuts it in half. So the two sides are equal. In the past, you could just write that down and move on with the math. But when it asks you to justify each step, you can't just say something mathematically. You have to justify why you're allowed to do that. So for example, in this case, this would be, we know that these are equal because of the definition of a bisector. A bisector means it cuts an angle in half, which means the sides are equal. And then from there, you would say, well, if RAB is X and BAN is 2X minus 75, then X equals 2X minus 75. But again, you have to justify that. You have to give a reason why you're allowed to do that. And in this case, we would call that substitution. So the math hasn't changed. You're still doing, mathematically, you're still doing the same things. But this week, you have to give a name to each step that you do. And I gave you a little cheat list that you can use. And we'll get into that here in just a minute. If you weren't here for class, it's online. You can print it off and look at it. But so what we're doing is basically we're writing what's called a proof, which is a convincing argument that uses reasoning. So I'll let you read through this on your own, but basically you do the math and then you have to justify why you are allowed to do that. So I can't, if I have X minus 5 equals 7, I can't just say that X equals 12. I have to justify how I got from this point to this point. And what we use to justify these things, like I said, I gave you a cheat sheet. So there's a bunch of rules, there's a bunch of properties that you can use to justify the math that you do. The first one, I'm not going to go through all of these, but I want to highlight a couple of them. Symmetric property means that if A equals B, then B is equal to A, which seems obvious, and it is, but if you have something written A equals B and you want to change it to B equals A, you have to write down that you used this property. Reflexive A equals A, again, an obvious one. Transitive property. If A equals B and B is equal to C, then obviously A is also equal to C. But you can't just say that. We can't say X equals Y and Y equals Z, so X equals Z. Mathematically, we can do that, but you have to say that it was the transitive property that you used. These four, you're going to use a lot more often than the first three. Addition property, if you add something to both sides, you have to say that you used the addition property. So back to our problem right here, my next step would be to get my x's on one side. So I would want a minus 2x from both sides. So I would end up with a negative x equals negative 75. But to get from here to here, I had a minus 2x from both sides. That's our subtraction property. So it's not enough to just minus it from both sides. This week you have to say why that was allowed. We can add to both sides. We can subtract from both sides and still be equal. Multiplying the multiplication property, if A equals B, then I can multiply both sides by C and they're still equal. If A equals B, I can divide both sides by C and they're still equal. Down here is where these ones you're not going to use as often, at least the last four. But this one right here, substitution and distributive, you are going to use a lot. Substitution just if A equals B, then we can plug in A anytime we see a B if we want to. That also goes for in my first example back here. If angle RAB, this angle, if that is equal to X, when I plug in the X instead of the RAB, I have to acknowledge that that was okay to do based on substitution. Distributive property is the only one that might give you a little bit of heartache, because obviously if A times B plus C in parentheses, that's equal to A times B plus A times C. You know how to do that. You know how to distribute. So if you ever have to distribute, you have to acknowledge that you use the distributive property. But there's one other time that we use the distributive property that may not look like the distributive property, and that's when we combine like terms. So as you're writing these proofs and it gives you these drop-down menus, you're probably not going to see combine like terms very often. There's a few problems that do, but when you're combining like terms, you're actually using the distributive property. And because it bothers me to tell you something and not show you, for example, let's say that we want to take 2x plus 5x, and that's equal to 7. I know that 2x's plus 5x's is equal to 7x's. But the way that we actually do that, the math that you don't see, is we actually factor out an x. So this becomes x times 2 plus 5, which becomes x times 7, which is just 7x. So when we combine like terms, we're actually using the distributive property. So for the most part on your homework, if the step requires distributing to get rid of parentheses, or if the step was combining like terms, you're going to call it distributive property. So that one's going to come up a lot. The last couple are just definitions. Definition of supplementary angles. Two angles that are supplementary mean they add up to 180. Definition of a midpoint. If M is the midpoint, then the two sides are equal. The two segments on the other sides of the midpoint are equal to each other. Segment addition postulate. Sometimes this one's easier to see with a picture. If I have a segment AB, if this is A and this is B, and I have a point P in the middle, the segment addition says that this point or this segment AP, if I add it to this segment, then it equals the big segment. That's called the segment addition postulate. There's also an angle addition postulate that looks the same. If I have an angle and I cut it, let's say that this is angle ABC, and we'll call this angle in here X and this angle Y. I can say that angle X plus angle Y equals the big angle, the angle ABC. That's called the angle addition postulate. Okay. Uh-oh, where do we go? Sorry about that. So we have all these different rules. Again, you have a cheat sheet that you can use on the homework. Any step that you do, you have to use one of these rules to justify that step, even if it's something that you do in your head. Okay. So for example, measurement of angle A equals the measurement of angle S. Remember, that's what this little M means right here, is measurement. So it's just saying angle A equals angle S and angle S equals angle K. Therefore, angle A equals angle K. So you would look at your list of rules to see which one that fits, which happens to be this one, the transitive. If A equals B and B equals C, then A equals C. So I would say that that is the transitive property of equality. Okay. This next one, 3x plus x plus 7 equals 23. And then after the next step, I've got 4x plus 7. So I have to justify, how did I go from here to here? Well, I had 3 x's and I added the x to it to get 4 x's. So that would be called the distributive property. So you'll have to name it. The last one, 4x plus 5 equals 17. Then I get to 4x equals 12. Well, I got there by minusing 5 from both sides. So that would be subtraction property of equality. So the math hasn't changed. You just have to give each step that you do a name. All right, so we're going to start with a couple easy examples, and then you can move on to the homework. Today, for the most part, the math is going to be done for you. You just have to fill in what the reasons are to do that. Okay, so if I'm given 5x plus 1 equals 21, 5x plus 1 equals 21, that's just my given. That's information that it gave me. I didn't do anything mathematically to get it. So we call that the given. And then from there, I get to 5x equals 20. Well, I got there by minusing 1 from both sides to get to this point. So we call that the subtraction of equality, because I can subtract 1 from both sides. Then to get from 5x equals 20 to x equals 4, I divided by 5 on both sides, which is allowed. In fact, that's one of our notes right here, right? Oops, got to go back to. The division property of equality says that I can divide both sides. So down here, I would put division property of equality. And that's what I wanted to prove, that x was equal to 4. So I'm done. Okay. Next one, a little bit longer. It says that C is the midpoint of AD, and it wants us to prove that x equals 6. And it also gives us these little pieces up here. So step 1, C is the midpoint. That was given. It told us that C was the midpoint. Then it says that segment AC is congruent to segment CD. Well, it's saying that this piece is equal to this piece, that they're congruent, which is true because of that definition of midpoint. So all I have to put here is that's true because of the definition of midpoint. If C is in the middle, then this side and this side are equal. That's the definition. Then it goes on to AC equals CD, and it gives you the reason that congruent segments have equal length. So if the segments are congruent, then that means the lengths are equal, which, again, that's an obvious one. 4x equals 2x plus 12. So what it did here is it took AC, it took this 4x and plugged it in where the AC was. And then it took the 2x plus 12 and plugged it in for the CD, which means we call that substitution. We substituted this number in for this length. And then part D, it wants you to use the subtraction property of equality. So in order to go from this step to the next step, to use subtraction, I'm going to subtract 2x from both sides. And I'm going to end up with 2x equals 12. So I use the subtraction property of equality to get from 4x equals 2x plus 12 to this point by subtracting both sides. Then from 2x equals 12, to get x by itself, I divide by 2. And I end up with x equals 6. And I did that using the division property of equality. So math you've seen, math you've done, just now we're giving it a name. For the most part, you're coming up with the names. There's going to be a few problems like this step 5 where it tells you what it wants you to do, and you just have to do that yourself. I don't think there's going to be any of those that are too confusing. Most of them are pretty straightforward. Well, let's look at this one. If we're given that xy equals 42, so this whole length, this whole thing right here is equal to 42. That's the given. And it wants us to solve for n. It wants us to get to this point. So we're trying to get n by itself. So from here, it tells us that xz plus zy. So it's telling us that this segment plus this segment is equal to the big one, which is true. That was that segment addition postulate. I can take the two segments and add it together to get the whole thing. Then from there, we go from, instead of an xz, it plugs in 3 times n plus 4, and it plugs in 3n, and it plugs in 42. So that step was a whole bunch of substitution. It plugged in a bunch of numbers where these variables were. Then from here, we go from 3 parenthesis n plus 4. It actually distributes that 3. So that step is going to be called distribution. Distribution. There's no T at the end of distribution. So that step is called the distribution property. We distribute and we get here. To get from there to this step, most of the problems are going to want you to put distribution as the answer. Distribution. But there's a few of them that one of the options is combining like terms. That doesn't come up very often, but that's what we did. We combined like terms. So that's called distribution, but it's also called combining like terms. All right. So to get from this step, when we go from 6n plus 12 equals 42 to 6n, we minus 12 from both sides. So we did that. We minus 12, which was the subtraction property of equality. And then from there, we divided by 6 on both sides to get to n equals 5. So that's the division property of equality. And now we have n equals 5, so we're good. Again, it's going to do most of the steps for you. Sometimes it might be a little bit hard to see how did they get from here to here. But if you just look at it as what would I do next? If I had 3n plus 12 plus 3n, I would put my 3n's together, which is what they did to get 6n. All right, I've got a little bonus here. We'll talk about it in class. If you're interested in getting some extra credit, come and see me. But other than the bonus here, homework 19 is what you're working on. It looks a lot like those 3 problems that we just did. This is due on Thursday. Whether you were gone or not, make sure you get that done. There's only 12 questions. There's a whole bunch of drop-down menus. For example, on this problem right here, when you're asked to put in these names, it gives you a drop-down menu that you can choose from, which I think makes the problems a little bit easier because you're not having to come up with the name. You're just having to pick which one is appropriate. So good luck. If you have any questions, come in and see me on your free time.